Hello student friends, we are discussing multiple choice questions on matrix spaces and this is our next question, 8th. If E is any subset of the matrix space M, then which of the following is always true? The alternatives are A, E is equal to, this is closure of E. Closure of E, we know the set which contains all limit points of E. E is always equal to closure of E. B, closure of E is contained in E. C, E and E intersection closure E is phi. And third is E is contained in closure of E or E bar. So which is true? Always true. And so if the set is closed, then we have E is closure of E. And this holds for the closed set. But if the set is open, then what we must have is E is subset of closure of E. This holds for both open and closed sets, and therefore this only relation is always true. A set is subset of closure of E, that we have seen. If X is E, it belongs to E, then X is a limit point of a sequence in E whose all terms are all x, etc. And that sequence has the limit x. So therefore that x belongs to E bar, and thus this relation is true. We have actually proved this result as a corollary. Next question, 9th, is in a matrix space M and rho, the sets M and phi are such that. So this is also a theorem that we have proved. Now what are the alternatives? M is closed and phi is not closed. M is not closed, phi and phi is closed. Third, both M and phi are closed. And D, neither M nor phi are closed. Now we have proved this as a theorem. In a matrix space M and rho, what is right alternative? That is, both M and phi are closed. M is closed, phi is also closed. And neither M nor phi are closed. So this is not true. And remaining are also not true. Only C is true. Both M and phi are closed. Next one, 10th, is in R1, the set of rational numbers is not a dense set, is a dense set, is an uncountable set, is a closed set. Now what is the alternative here? In that, after defining a dense set, a set A is said to be dense if closure of that set is equal to the entire matrix space. That is the definition. And after that definition, we have studied an example. Now what will be the correct choice? So you should think about it, and for these answering these multiple choice questions, you should thoroughly study the definitions and the theorems that we have proved earlier or we have studied earlier. And depending on these basic part, the multiple choice questions may be asked. So here R1 is not a dense set, is not true. It is also not uncountable, it is countable, and it is not a closed set, and it is a dense set because closure of rational number is equal to real number. So this is the correct alternative. Next one is every singleton set in discrete matrix space RD is what type? Half open, both open and closed, closed, and D open. So what is the correct alternative here? We know singleton set A in a matrix space can be expressed as open ball about A of radius 1, and therefore a singleton set A in a matrix space is open, and we know that a singleton set is always closed. So therefore the correct alternative here is, it is in discrete matrix space, it is both open and closed. So this is the correct alternative. Next one is, if G1 and G2 are open sets of a matrix space M, then what about their union? G1 union G2 is, alternatives are open, second closed, third alternative C is both open and closed, and neither open nor closed. These are the alternatives. This is a direct theorem. We have proved if G1 and G2 are open sets, then they are arbitrary union, countable or uncountable also. Union is always open. So this is the correct alternative. And what about the 13th next question? In let In is this open interval -1 by n and 1 by n, then what will be intersection of these intervals? What will be the intersection? And as we see, n takes value from 1 to infinity. So if you take run n from 1 to infinity, if you take it n is equal to 1, then this intersection will be -1, 1, first set. If n is 1, n is 2, then that is -half plus half. Intersection n is 3, -1/3, 1/3, and so on. Intersection. As we see, n becomes infinite. 1 upon n tends to 0. And therefore this is 0 and this is 0. That is, it is singleton set 0. And intersection of all these is the element which belongs to every set is 0. And therefore the intersection of In is 0. So this is the alternative for this, correct alternative for this. And the last one is, not last one, but 14 is, let G be an open subset of a metric space M. Then what is complement of G? Complement of G means those elements which are not in G but in M. Those elements of M which are not in G is what type? Open, closed, or phi, or entire M. And we have a result or a theorem that complement of an open set is closed. And therefore if G is open, then complement of G is closed. So this is the correct answer. And conversely also, complement of an closed set is, or complement of a closed set is open set. Now the next is 15th. If F from M1 to M2, where here it is assumed that M1 and M2 are matrix spaces. Maybe M1 and row 1, here M2 and row 2. But the function from M1 to M2 is continuous. Then F inverse of capital F is closed subset of M1 whenever F is, which is the correct. Whenever F is closed subset of M2, closed subset of M1, open subset of M1, and open subset of M2. So what is the here for continuous function? We have proved the two theorems. One related to open set, another related to closed set. That means if F is continuous function from M1 to M2, then F inverse of F is closed subset of M1. So here it is subset of M1. F inverse of capital F. Whenever F is, now where it must be? If F inverse of F is in M1, F must be in M2. That we have seen earlier. And if function is continuous, it sends closed set to closed set, or inverse image of closed set is closed, inverse image of open set is open. That two separate theorems we have proved. So therefore F must be closed in M2. That is the correct alternative. So F is, now here what are the alternatives here? F is closed subset of M2, closed subset of M1. F cannot be in M1. F inverse of F is in M1, therefore F must be in M2. So it is necessarily in M2, and again it must be closed because this inverse image is closed. So this is given closed, so therefore it is closed subset of M2 is the correct alternative. So these are some of the multiple choice questions we have studied on the part that of metric spaces. That means definition of metric, then limits of metric space, open sets, closed sets, etc. So that you can get an idea about the multiple choice questions and you can easily solve these questions. So remaining part we will continue in the next lecture. Thank you.